Welcome to Study Loop.
Welcome to the problem number 22.60. This is chapter 22, Gauss law. In this question, we are given that there is a sphere having capital R radius and is an insulating material, carries volume charge density rho, and we are given that the electric field between R region, between R less than capital R, between means that between this sphere as an function of E versus R as a linear graph. So due to this linear graph, we have to find out the volume charge density. So this row. So let us find out the E versus R relation using our Gauss law. So using Gauss law, we have E dot ds equals to Q enclosed over epsilon naught. In this question, we are finding out the electric field inside that sphere. So we take a Gaussian surface having radius small r. So Q enclosed would be rho times volume of the that sphere, which is 4 pi over 3 r cube. So this gives us E dot ds. Now the ds is the area of the sphere and the electric field is symmetric. That means the integration comes out and this gives us 4 pi r square. So rho times 4 by 3 pi r cube over epsilon naught. So this gives us E equals to rho over 3 E naught r. So this is the relation between E and R. So this is a linear relation. So E is directly proportional to R, and this is consistent with the graph. So let us find out the slope of this graph. So you can plot this graph using Mathematica or some online graph plotter or maybe Excel. I have plotted this graph using Mathematica and I have found out the slope. So slope comes out to be 7.5 into 10 raised to power 6 Newton per meter coulomb. If you want to find out the slope directly from this graph, so you take some point here and you take some point here, and first, so that finding out, so this the slope is equals to delta y over delta x. So delta y is our, so let's take this is E2 point and having R2 point. So this is E2 and this is R2. You just need to find out the values of R1 and E2 and even and R1. So this will give us E2 minus E1 over R2 minus R1. You can find this slope using this one. So the exact answer comes out in this situation because the slope is linear or the relation is linear. So that's why we can find out the exact value using this approach. So the slope comes out this one. So we know that y equals to mx plus c. C is equals to 0, and so using both conditions c is equals to 0, so slope which is equals to m and which is equals to, using this condition, so we have y equals to e and x equals to r. So comparing this equation, slope should be rho over 3 e naught, which is equals to this value. So we have rho 3 e naught times slope value. So putting the value the E naught, we have E naught equals to 8.854 into 10 raised to minus 12 Coulomb square over Newton meter square. So putting all this value, which is equals to 3 times 8.854 into 10 raised to minus 12 times 7.5 into 10 raised to power 6. The units of the rho or the volume charge density is Coulomb per meter cube. So this comes out to be 1.99 into 10 raised to power minus 4 Coulomb per meter cube. So that's your answer for this question. Thank you for watching the video.